Dear friends, most popular topic, Einstein's very popular experiment and equation it is we are going to discuss in this video. So this is the important for 8 marks question, and there are 2 short answer questions are included in the same topic. That's why you have to watch the video up to last without any skip. So dear friends, here what is mean by photoelectric effect? Photoelectric effect. Photo means light energy. When certain amount of light energy is incident on the metal surface, from that electrons are liberated. When certain amount of frequency of incident radiation or radiation incident on the metal surface, then the electrons are removed from the metal surface. That should be what we call photoelectric current. So dear friends, here this is the one metal surface. On that metal surface some light is falling. From that electrons are removed. And that phenomena what we call photoelectric effect. What we call photoelectric effect. Photoelectric effect. And those electrons are called photoelectrons. What we call photoelectrons. So this is simply about the what is photoelectric effect. So dear friends, in a metal there are so many number of electrons are there. Some electrons are strongly bonded to the nucleus, some electrons are away from the nucleus, they are having less interaction force between the nucleus and those atoms, what we call generally free electrons. So when certain amount of energy is falling on the metal surface, due to that these free electrons are liberated from the metal surface. That phenomena what we call photoelectric effect, and those electrons are called photoelectrons. So here children, there is one word and it is important for 2 marks also, that is the work function. What is mean by work function? Work function is nothing but the minimum frequency of radiation. The minimum frequency of radiation to remove the electron from a metal surface is called work function. Clear? So here the work function should be given by the formula pi r w is equals to h mu naught. Clear? To remove the electrons from the metal surface, certain amount of frequency is required. That should be what we call work function. The minimum frequency required to remove the electrons from the metal surface is what we call work function. So here there is one important equation is there for the photoelectric effect, that should be given by the Einstein, and so it is knownly or famous as the Einstein's photoelectric equation. What is Einstein's photoelectric equation? So according to the Einstein, the photoelectric equation should be given by the formula E is equals to W plus of mv square. In that one, what is E? E is the energy of radiation, what it is incident on the metal surface, energy of radiation. And what is W? Work function, W naught or pi d, sometimes it is also known as pi. What is work function? Just now only we discussed what is work function. The minimum amount of frequency of radiation is required to remove the electron from the metal energy. Here now kinetic energy is what? Of mv square. What is? Of mv square. So these are the terms in the Einstein's photoelectric equation. E is equals to W naught plus of mv square is called as the Einstein's photoelectric equation. And what is the energy of radiation, what it is incident on the metal surface, and what is W naught? Work function. What is of mv square? Kinetic energy. So according to that equation, we have to say that here the energy, what for example it is the metal surface, what we are saying, some metal surface. Now here some amount of energy is falling on the metal surface. That is what we are going to take. E is equals to h nu. Clear? So that amount of energy is incident on the metal surface. Due to that, the electron is liberated and the electron should be moves. So electron can be in moving or motion. So here, due to the amount of energy, here two things are happening. The first thing is what? Electron is liberated from the metal surface, and not only that, the electron it is in motion. That means the energy what it is incident on the metal surface, that is going to be remove the electron, and that should be imparted some kinetic energy to the electron. So to understand, simply I am saying now here, for example, here E is equals to h nu. We are saying that some 100 units of energy is incident on that one. Clear? In that 100 units, 70 units are utilized to remove the electron, and remaining 30 units are, they will give some energy to the kinetic energy to the electron. So simply here what you have to say, 100 units are incident on that one, and in that 70 units are required to remove the electron, and remaining 30 units are to give the to move the electron, or to give the some kinetic energy to the electrons. So that's why here according to the Einstein, what you have to say, when certain amount of energy is falling on the metal surface, due to that two things are happening. One is electron is liberated, at the same time the electron will gain the kinetic energy. So this is simply about the Einstein's photoelectric equation. So dear students, so we will go for detailed equation explanation. Now here what we are saying now, W is E is equals to what? H nu, energy that is going to be incident, and W naught or work function what it is, right? H nu naught. The equation for work function is what? H nu naught. Here nu naught is called threshold frequency. What is nu naught? Threshold frequency. The minimum frequency required to remove the electron from the metal surface, that is what we call threshold frequency. And remaining is what? Kinetic energy of mv square. So simply here I am going to write of mv square is equals to h nu minus h nu naught. Clear? So here we have formula is there, C is equals to nu lambda. From that what, right? Nu is equals to C by lambda. Nu is equals what? C by lambda. Then here instead of nu what you can write? C by lambda. So therefore here this is what I am going to write, kinetic energy, that is what? Hc by lambda minus Hc by lambda naught. Again here what is lambda naught? Threshold wavelength. Then kinetic energy equals to, we can write h of C by lambda minus C by lambda naught. This is another form of Einstein's photoelectric equation. Clear children? Now we can go for in detail explanation of experiment. Clear? On board it is there, the diagram, you can observe very carefully here. Very simple experiment it is there. So dear students, so what you are finding, and this is now what is evacuated glass tube or discharge tube. Clear? For that there is some quartz window it is there, quartz window it is there. Clear? This is what? Quartz window. Clear? And this is the source, from that source the light is falling on the S quartz window. To that the light is incident on the this one. Clear? So children, in the diagram one glass tube is there, for that two electrodes are there, one should be taken as cathode and one should be taken as A, and here cathode is nothing but photosensitive material. The metals which are going to be sensitive to the light, they are called photosensitive material. When the light is coming from the source and thus should be passes through the quartz window, when the light is falling through the quartz window, that is moving like a beam of light. Before quartz window that should be in different directions, but after when it is entered into the quartz window, it seems to be like as a beam of light. That should be incident on the cathode. And now here there is one voltmeter is there. That voltmeter should identify the or explain about the potential difference what it is between the two electrodes. Clear? So the potential difference what is maintained, that should be explained by the voltmeter. This is what? Voltmeter. And mu a microammeter. So now coming to the procedure, children. When certain amount is coming from the source and there should be incident on the cathode, that is the photosensitive material. Due to that, the electrons are liberated, and not only electrons are liberated, due to the incident energy, the electrons are moving from cathode to anode. So it is having some positive charge, it is having some S like that. So these electrons are moving towards the collector. Initially A is given to positive and C is given to negative. That's why the electrons what are released, they are going to be towards the collector. Anode is nothing but it is what? It is collector. This is what? Collector. Collector means, why you are saying this collector? Collector means it will collect the electrons which are coming from the cathode. So while the energy is continuously falling and the electrons are liberated continuously and they reaches the collector. So then the amount of electrons should be moving, that should be what we call current. The photo current should be represented by the microammeter which is in the circuit. So this is the process what it is, photoelectric effect. Very simple. Light is falling on the metal surface, from that electrons are released and they are moving towards collector. The amount of current is here shown by the microammeter. So you have to identify that here what are these? These are the photoelectrons, and the current shown by the microammeter is what? Photo current or photoelectric current. So dear students, here mu A value is more means more number of electrons are reaches the A. Clear? So this is the phenomena experimental procedure what we have in your textbook. Now you have to identify the relation between the intensity and photoelectric current. Relation between now intensity and photoelectric current. Clear, children? So to understand that, we have to maintain two things are constant here. First thing is potential difference is constant and frequency of radiation. Frequency of radiation both must be maintained constant. When these two are constant, or by maintaining the potential difference and frequency both are constant, then what you can observe here, we have to increase the intensity of radiation. When intensity is increased, number of electrons which are released from the cathode also increases. When more number of electrons are increased, and more number of electrons should be reached by the collected by the collector. That means simply here there is some proportionality between the intensity of radiation of light and photoelectric current. When intensity is increased, the number of electrons emitted from the cathode also increases. Obviously, the number of electrons which are reaches the anode also increases. So there is some directly proportionality between intensity of light of radiation and photoelectric current. That should be shown by the graph like this. The straight line means what? There is some directly proportionality between intensity of light and photoelectric current. When it is possible, by maintaining the potential difference and frequency of radiation both are constant. So this is the relation between intensity of light and photoelectric current. Now let's see the relation between the potential and photocurrent. To understand the relation between the potential and photocurrent, we have to maintain the frequency and intensity of radiation is constant. So when we are maintaining these two are constant, one is frequency, next one is intensity of radiation. When maintaining these two are constant, then the relation between the photoelectric current and intensity should be, photoelectric current and potential should be is as shown in this figure. Clear, dear students? On x-axis we are taking potential, on y-axis we are taking photocurrent. So for this curve I1 is, this is the I1, intensity I1, and this is the I2, and this is I3. So I3 is greater than, I2 is greater than I1. Here I means intensity, not current. Okay. So I1, I2, I3, when we are taken intensities, I3 is the greater than I2, I2 is greater than I1. Okay. Now look here, very important to understand that. Here I already told you, to understand this, what it is, the frequency is going to be maintained constant and intensity also going to be constant. Now children, here you can observe here, this is the middle one, origin. When we go for this direction, the collector potential is increase. Collector potential is increase. To understand simply here, this is the origin and this is now plus x and this is the minus x. This is the positive x-axis and this is the negative x-axis. Clear children? So when the positive is here, nothing but positive potential. While we are going from mean to the that side, the potential is increase in the positive. And now when we go from here origin to the this side, the potential is increase in negative manner. So here what's happened, let's see. For positive potential, you can observe here, when the potential of the A is going to be increase, the positive value of A is continuously increases. Then what you can observe, the number of electrons should be reaches also increase. When there is small potential for A, then it will collect the less number of electrons. Clear? Already we discussed, these electrons are coming from cathode. The more number of electrons will be collected when the positive is more here. When the collector has positive potential, then electrons is increase. Collecting of the electrons is increase. The value of A is increase. When it is increase, we are going from O to positive x-axis side. Then, for example, here 100 electrons are liberated. Then the maximum number of electrons are received here. Then the reading shown by the microammeter is maximum. Then that condition is called in this graph, that is the saturated, what it is, saturation current, saturation photocurrent. Clear? For the first time we are taking I1. What is I1? Amount of light incident on that one, and we are maintaining frequency is constant. Then what you have to say, when I1 is incident on the quartz window, then the number of electrons are received, how many we are saying here? 100. So then the maximum number of electrons are emitted, the maximum number of electrons are collected. Then this photocurrent is saturated. That is what you have to say, saturation current. And after that, now we have to take the amount of light that should be having intensity I2. So when the color filter changes, intensity also changes, like that. Simply here I2 current is there, that should be incident on that one. Then 150 electrons are released. 150 electrons are released, and again the positive potential of A is increased. Then that should be collects the 150 of electrons. For example, I am saying here. So 150 release now S. Then this amount of saturation current is available for intensity I2. After that, again we are changing the intensity of light, like I3. Then it will collect the 250 electrons are released and 250 also collected. Then we are reading this the saturation current. So that means what? When the intensity is increases, photocurrent also increases. Clear? When intensity changes, photoelectric current also changes. Clear? So that's why here what you have to say, when the positive potential of the collector is increased continuously, the photoelectric current is increases. When intensity changes, photoelectric current also changes. While we are increasing the positive potential of collector, after some time the maximum number of electrons are reached by the collector. At that time the current is going to be saturated. The maximum current is possible, that is we are showing here. I1, I2, I3 intensity are there, further saturation currents are reached. After that, Even though we are increase the intensity, there is no rise in the photoelectric current. That means what? It reaches the maximum value. After that, even though we are increasing the intensity of light, or continuously rays is falling. To understand that, first time what I told you, for intensity I1, 100 electrons are released and another is reached. So after that, the light is continuously falling on it. Then there is no additional electrons are liberated and they are not reaches the collector. When we can change the I1 to I2, then again number of electrons are released. Clear? So simply have to remember, children, no need to confuse, very simple manner. When intensity is increased, the maximum electrons are liberated and those maximum electrons are collected. After that also the light is continuously falling on that one. There is no rise in the photoelectric current. That's why these are called saturated current. So this is about the collector potential increased manner and photoelectric current. After that, what happened? Now we can go for the potentials are in reverse manner. That means initially for the first half what we are given, positive potential is increased for A. Now the negative potentials are given, negative charge is given to the A. That means here there is one commutator is there. Due to that commutator, the polarity of A is changes. When A is given to negative and those electrons which are coming from the cathode, those are strongly repelled by the collector. Even though repulsion is there, some more strong electrons are reaches the collector, then it will show some reading. Clear? So for this part, second part, what I am saying, for A we are given negative potential, the charge of electrons are negative and this is also negative repulse. That's why the value of current is going to be decreases. Clear? For which value the photocurrent becomes zero, that particular potential is called stopping potential. What is meant by stopping potential? On decreasing the potential at particular value of potential, photocurrent becomes zero. Photocurrent means zero means what? No electron should be collected by the collector because of strong repulsion between the electrons and negative charge of the collector. Clear? That's why that potential is what I have to say, stopping potential. For every intensity here, while we have positive potential value maximum, saturation is current is there. When we are decreasing the potential, stopping potential is there. That's why from this figure what I have to say, even though intensities are different, they have one common potential, stopping potential takes place. Clear, children? So this is about the stopping potential. While we are maintaining frequency and intensity is constant, here the potential value is changes the photoelectric current. While we are using the positive potential, the photocurrent is maximum. When we are decreasing the potential, negative potential, we are increasing the negative potential, then the value of photocurrent becomes initially decrease and finally reaches the zero. That particular potential what we call stopping potential. Clear, children? So this is the relation between the potential and photoelectric current. Now let's discuss about the relation between the frequency of incident radiation and photoelectric current. Let's see here, there is one graph, it is there. This is the collector potential positive and this is the collector potential negative and this is the photoelectric current. Clear? So to understand that, children, in this case we have to maintain the, here I is constant and V is constant. So here I means intensity and V means potential. Look here now, children. So from this graph you have to say, when the potential is, we are maintaining some positive potential, for that saturation current it is there. So first we are taken one particular intensity, that we having frequency nu1, and second intensity that we having frequency nu2, and now it is nu3. Now we are changing the only frequency, not intensities. Clear? The nu1, nu2, nu3 are there. Here nu3 is the frequency of third intensity and second and first one, like that. So from that, what you have to say, from this graph you have to say that different frequency of radiation has different stopping potential. Clear? From this graph you have to understand the main point is what is the relation between the frequency of incident radiation and photocurrent is what? Yes, when the frequencies increases, the stopping potential value also increases. For every stopping potential, there is one cutoff frequency. Is the cutoff frequency is there. Cutoff frequency means, just now we discussed what is stopping potential. For which potential photoelectric current is 0, that should be what we call stopping potential. At stopping potential, the frequency of radiation is what we have to say, cutoff frequency. What is cutoff frequency? That's why here the frequencies are having different intensities, are having different cutoff frequencies and different stopping potentials. So but they have same saturation current is there, but different stopping potentials, So that's why here what you have to say, children, the amount of photoelectric current from this graph, we have to say that the amount of photoelectric current is independent of frequency of radiation. Clear? So already we discussed, when intensity changes, number of electrons radiated also changes and photoelectric current is increases. Photoelectric current is mainly depend upon the intensity of light, but not intensity of frequency. But the moving of electrons will decide by the frequency. That means the kinetic energy of the photoelectrons is depend upon the frequency. That is the relation between the frequency and photoelectric current. Clear? So simply you have to remember 2 points. The first thing is what? For different frequencies also saturation current is same. And the second point is, when frequency increases, stopping potential also increases. For highest frequency of radiation, the stopping potential is more, negative stopping potential is more, or negative potential is more. So and next thing is what? Frequency can affect the only moving of electrons, not releasing of electrons. So children, this is the simply about the what is Einstein's photoelectric equation, and what is the relation between the intensity and current, what is the relation between the potential and current, and what is the relation between the frequency and current. So I hope you understand. If you can understand this one, like, share, comment the video, children. So my request is, please share my channel to your friends who require it. Okay, thank you for watching. Bye, take care.